Hi there. Some of you were asking for a little bit more explanation on why naive Bayes was so poor for the Tic Tac Toe dataset. So here I have loaded that dataset into Weka on the preprocess tab. Now I'm going to go to the classify tab. Now you'll see here that I have set this up to do an experiment with a Bayes net instead of naive Bayes. And we haven't talked about Bayes nets yet, but so let me just tell you that if you run a Bayes net in a simple mode, where you tell it to keep the simplest possible structure, it's essentially exactly the same as the naive Bayes algorithm. Now, if I've run an experiment with Bayes nets, and I can bring up the graph that it learns, and it's exactly the structure that indicates that it was a simple naive Bayes model, because we've got here all of our features and each one has a simple relationship with the class value. Now the reason why I've used Bayes net is because it has this nice little interactive visualization so that you can actually see the probabilities that were learned in a simple fashion. If I click on a node, I can see a table that tells me the conditional probabilities. So the conditional probability that this position 1 is x given that the class value is positive is 0.471, and the conditional probability that position 1 has an O given that class value is positive is 0.302. So that's how you would read this table. So this is a compressed or just very compact version of what is the set of probabilities that are learned. The conditional probabilities associated with each of our feature values in connection with each of our class values. So you can see here that although there's a little bit of a preference for x to be associated with positive and O to be associated with negative, even here they're very, very close in this node. If we look instead at the middle node, the story is different. Here we see that having x or O in that box really skews you in favor of positive or negative as the class. So we see that this conditional probability is much, much stronger. Now, all of the ones apart from that middle one look very much like that first one that we looked at, where it's not 50-50, but it's not very distinct. It's just giving very little traction towards the classification. And so that's why naive Bayes did very poorly, because the only strong conditional probability is the set of conditional probabilities that are coming out of that middle square. So because of that, essentially what it's learning is that it's very strategic to take that middle position, but apart from that it isn't learning anything, because you just conclude very little from knowing that there's an x or an O in one square. And you can see, if you look at this, what does this mean? I mean, so what is the information that's being considered here? All we're looking at is one square by itself. So we have these conditional probabilities in each of our squares, but each time we have very little visibility into the whole board. And that's why naive Bayes does very poorly when the representation is like this.